appreciate it. Hello, everyone. My name is Doug Lovelace, and I'm going to be talking to you today about structural concerns with electric and hybrid aircraft. Now, with many companies emerging into these inner city air vehicles, if you want to call them like air taxis, the efficiency of these vehicles have a large impact on the design, the layout, and even cost of these aircraft. Now, Mitch talked to you about efficiency from one side of the fence. Now, I'm going to be looking at efficiency from more of a structural concern standpoint. So with these new radical designs comes the concern of structural safety integrity. So as more propulsion systems are being put on the wings, as Mitch had pointed out, like the X-57, up to like 14, motors on the wings, there is, structural safety and integrity concerns because now you're adding mass. You're looking at the placement of these motors that, can actually cause some serious structural concerns. Two of the main ones are classical flutter and whirl flutter. Now, the first one I'm going to talk about is classical flutter. So the location of these propulsion motors, or really any large mass on the wings, can lead to classical flutter issues as the wing and wingtips are very sensitive aeroelastically. So, just the placement of where these motors are at, can cause classical flutter issues. So classical flutter is basically an instability due to an interaction between aerodynamic, inertial, and elastic forces. So basically the airflow, over the wings can sometimes line up with like first bending, second bending, of the wing. So with these vehicles, and the new designs, all of a sudden there's a new growing concern for like classical flutter. Well, now because of so many propulsion systems and the efficiency that is needed for these aircraft to fly long distances, to actually have like vertical takeoff and landing, the majority of these propulsion systems have propellers, because a propeller is way more efficient at these lower RPMs. So, from a whirl standpoint, as the propeller is rotating, the speed at which it's rotating can easily line up with these, bending frequencies, these torsional frequencies. So whirl flutter all of a sudden becomes more of a concern. So unlike classical flutter, whirl flutter is mainly sensitive to the stiffness of the nacelle or the container that the motor fits in and the attachment to the wing. So, I mentioned that, some of these vehicles have vertical takeoff and landing. Well, the way they achieve that is sometimes taking that motor and rotating it 90 degrees to get vertical lift, but then after the vertical lift, horizontal to get forward motion. Well, obviously, if the motor can rotate, then there's less stiffness between the motor and the attachment to the wing. So that's why all of a sudden whirl flutter is a concern. So there are certain structural tests, and because of the structural concern or integrity of these vehicles, has to be documented, then typically you would do what's called a ground vibration test. And because these vehicles are, again, trying to be made as efficient as possible, then different things like different materials for the fuselage. Some of these aircraft are being made out of composite. Again, some are taking basically a helicopter and putting a wing across the top. So these different designs are requiring all these airframe designers to do what's called, again, a ground vibration test, where you go out and excite the structure in the frequency range of interest and acquire all that data and then analyze it to calculate the different mode shapes. So basically understand and characterize where like first wing bending is, the first bending of the fuselage. But now all of a sudden the vertical, lateral, and torsional modes of these different propulsion systems comes into play. So at HBK, we can provide you the tools to do all these different types of tests and measurements and all the analysis that needs to be done.
In summary, HBK really presents ourselves as a single source provider. And as we've seen today, in this new novel aerospace application, the electrical powertrain and structural characterization really complement each other. The electrical and the motor properties feed into the structural dynamics. And at HBK, we have electric motor testing solutions that can feed data and information into some of our structural evaluation solutions like ground vibration testing and analysis. Now, this makes it really convenient for analyzing your aircraft. And the reason we're able to do this is because we provide the complete measurement chain. We have sensors, acquisition, experts like Doug and myself, data processing tools, and engineering services if you really need to call in for help. So with that, we like you to think of HBK when you're going in for your testing needs. And we'd like to thank you for your time. And if you need to reach out to Doug or myself, please feel free to send us an email. And if we don't know an answer, we certainly know somebody who does.